Hello everyone, welcome to a week 5 video on factoring quadratic equations from my Algebra 2A classes. So we're going through week 5. Make sure you are accessing our textbook and going through the sections in there. Make sure you're watching this video. You can use, again, the resources as you're working on all your assignments this week. Our objectives, what we're going to be learning is, we're going to define what a quadratic equation is. We're going to look at, given a quadratic equation with a leading coefficient of 1, how to factor it into two binomials. We're going to talk about if I given any quadratic equation, we're going to factor it into two binomials. We're going to identify special cases to help factor. And actually, if I give you a quadratic equation, we can use factoring to then help solve it out. And then finally, we're going to do a little bit with radicals. Given an expression with a radical, learn how to simplify the radical expression. So a lot of kind of nuts and bolts skills. Notice there's no problem solving. It's just factoring, rewriting, digging into some nitty-gritty algebra to help us be able to do tougher, more difficult problems in the future. So far in this class, we've been working with linear equations and systems of linear equations, graphs with straight lines, solving equations, functions, all that kind of stuff. But we're switching gears now and looking at a whole nother class of functions, and that is quadratic functions. All quadratic functions can be written in this form, y equals ax squared plus bx plus c. And when we say quadratic, we mean we have an equation and there is some term in there that has a variable to the second power. It's that second power that makes it quadratic. There's no more than that. So there's no thirds or fourth powers. Those are other forms of polynomials. So the highest power is the second power, but we have to have a second power. Notice there's an x to the first power, and then there's still a constant term. We can have those, but we don't necessarily have to have those. But we have to have an x to the second power to be considered quadratic. And again, quadratic stuff shouldn't be new. Again, we did a lot when you take your Algebra 1 class. Usually you spend a good amount of time learning with quadratic equations as well. So we're going to continue to build on that stuff, refresh, review, and get a little bit more complex with understanding quadratic equations. This week in particular, we're going to review factoring, taking quadratic equations, rewriting them different ways, and learning how to take a polynomial and split it into little polynomials. But factoring is a helpful algebraic skill that we use throughout our time working with quadratic equations. And it lets us get into more complex polynomial functions as well. So factoring is the opposite of multiplying. So let's first review multiplying polynomials. Make sure this stuff is fresh in your head. Here I've got x minus 3 times x plus 9. I've got two binomials, again, two terms, a binomial here, x minus 3, multiplied by another binomial, and I want to multiply it together correctly. All right, well, let's do that. So if you remember, there's the FOIL method, there's the distributive method. Basically, each term needs to multiply every other term. So I'm going to start with this x, and it needs to multiply that x over there. So that gives me x squared. This x also then needs to multiply the 9, so it's a positive 9 term. So x times 9 gives me plus 9x. But now I also need to multiply by the other. This is a negative 3 term, and if it's helpful, you can change it to plus negative 3. So it's negative 3 times x, so it's plus negative 3x. And the negative 3 also multiplies the 9. So negative 3 times 9 is plus negative 27. There we go. If we're multiplying two binomials, I should end up with 4 terms. We're still not quite done. I need to simplify things out. So I'm going to look for things that add together, like terms. There's x squared. I can add these two together. 9x plus negative 3x gives me 6x. And I have the negative 27, but I can rewrite it as negative 27. So there you go. That's multiplying. That's taking two binomials, multiplying to get this trinomial right here. There's 3 terms, right? That's setting us up for what we're doing in reverse. What we're doing this whole week with factoring is taking a trinomial and doing it in reverse, figuring out how to factor it into little binomials multiplied together. So hopefully you got the big idea about what we're doing. I want to take this, a trinomial, and rewrite it as two binomials. Factoring is the opposite of multiplying. When we factor, we're taking our large polynomial, we're separating it into two or more polynomials multiplied together. We're going to do lots of examples of that. So here we go. Factor the following quadratic equations. So we're starting with these ones. These are actually easier ones because these have a leading coefficient of 1. There's a 1x squared. There's a 1x squared here. There's no number in front of the x squared. So when I factor it, it makes it really easy to figure out how to divide it into two binomials. Now, working with leading coefficients of 1 when I have a trinomial, what I do want to pay attention to is what is in front of the middle term and what is the constant at the end. So if you remember from quadratics earlier, we have these coefficients a, b, and c, right? Every quadratic, we have some value ax squared plus bx plus c. And we really want to know what are a, b, and c because they help us in factoring, they help us in the quadratic formula, they help us in all sorts of things in understanding quadratics. So in this particular problem, my value for a is 1, so leading coefficient of 1. My value for b is 7, right there. My value for c is 10. Now if you remember multiplying, this 10 involved these two terms multiplying together, right? We would distribute them out and they would multiply to make 10. So when I think about it, I need two numbers that multiply to 10. But this 7 right here in the middle involved adding my two middle terms together. Remember last example, we added the middle terms. So I need two numbers that also add up to 7. So that's how you go about doing this. What are two numbers that multiply to 10, that add to 7? Well, to get 10, it's either 5 times 2 or 10 times 1. And I really quickly see that 5 times 2 also adds up to 7. So this must factor into x plus 5 times x plus 2. There's my factored form of x squared plus 7x plus 10. These are the same thing. To double check, let's multiply it out, right? So x times x gives me x squared. X times the 2 gives me plus 2x. 5 times the x gives me 5x. And 5 times 2 gives me 10. I combine my middle terms, right? There's 2 plus 5 gives me 7x, and then 2 times 5 gives me the 10. And I see I get right back to what I started with. So all this is checking our work by multiplying, because when I factor, it's the opposite. So there we go. This is the answer that I want, however. When I'm asked to factor it, that's my factored form. Let's do another one, but let's go a little bit quicker through it. So on this one over here, again, I got a leading coefficient of 1. My value for b is a negative number this time, negative 5. And my value for c is negative 24. So I want to find two numbers that multiply to negative 24, but that they add to negative 5. It's a little bit trickier when you think about negative numbers, but my numbers are going to be negative 8 and positive 3. Negative 8 times 3 gives me negative 24, but negative 8 plus 3 gives me the negative 5. And if I check my work by multiplying out, x times x gives me x squared. X times 3 gives me 3x. Negative 8 times x. And negative 8 times 3. And I can see my middle two terms do add up to negative 5. So it all checks out. You should be doing this as well. When you do the problems, check them out by multiplying and make sure things are working out correctly. There's a couple examples about factoring. These are easier factoring problems because your leading coefficient is 1. All right, so in general, summarize it up. If you have a quadratic equation, you got ax squared plus bx plus c, and your leading coefficient a is 1, you just look for two numbers that add to b, but also multiply to c, and then it factors the two binomials with those two numbers. All right, let's take a look at another one here. What if I have a quadratic equation and the leading coefficient isn't 1? So let's play around with this one and see if we can factor it out and figure out what we got going on here. So I do know I'm trying to factor it into two binomials. And I do know when I multiply it together, the first two terms, what's here and what's here, have to multiply to make 2x squared. And what's here has to multiply to make negative 45. And the tricky part is I need things to add up to 13x. Now since I have a 2 in the front, it makes it a little bit trickier. But let's think. The only way to multiply to get 2x squared, I need an x times x to get the x squared. And to get 2, the only way is to have 2 times 1. So I know it has to be a 2x times x, because when I multiply those together, that gives me 2x squared. All right, so I'm halfway there already. But now let's look at, switch to magenta. Let's look at this negative 45. I need two numbers to negative 45. So let's list out all the factors. So I could have negative 5 times 9. Or I could have positive 5 times negative 9. What else to get 45? I could have 3 times 15. And that could be positive or negative. The 3 has to be negative or the 15 has to be negative. 2 is not a factor. We got 5. 10 is not a factor. I think those are all the factors. I'm looking for 5s, 9s, or 3s and 15s. And now here's the part where it gets a little bit tricky, is figuring out how to get this 13x in the middle. This 13 is positive, so whatever the net effect is, I need to have a positive number be bigger. So I'm going to think, well, maybe I need my 15 here to be more with the positive number. So let's just guess and check and try some things around. I'm first going to try negative 15 and positive 3. Now I know the negative 15 times the 3 is going to give me negative 45 at the end. But what I need to check is, am I getting that plus 13 in the middle? So let's see if this green, oh, that green is not a good green. Let's switch colors here. Let's go to red. So if I do my middle two terms, 2x times 3 is going to give me 6x. And then I have negative 15 times x is minus 15. And right away, I know I'm not good because 6x minus 15x is negative 9. That's not the 13 that I need. So I'm going to rule out that one. It is not negative 15 and it is not 3. If I switch them, if I put negative 15 here, I'm going to end up with negative 30 plus 3x. That's not right either. So I'm sort of doubting myself. I'm thinking 15 and 3 are not what I want. So let's now try 5 and 9, some combinations of 5 and 9. I do know that if I have 2 times 9, that gives me 18, and 18 minus 5x is 13. So let's try that. So let's put a 9 here. I'm going to make it positive 9. And let's put a negative 5 right here. And now let's check all that out. I know, again, 2x times x gives me 2x squared. That's fine. I know negative 5 times negative 9 is negative 45, so that works. What I'm checking is, am I getting this 13x in the middle? So 2x times 9 is 18x. And then negative 5 times x is minus 5x. And there we go. Those two combine to make 13x, positive 13x. So my factored form is 2x minus 5 times x plus 9. This is the same expression as that original trinomial there. Now what we just did here was a guess and check method, right? We guessed a couple times. We did an educational guess, right? We looked at all the factors to get negative 45, and then we tried them until we found ones that successfully multiplied. So we would guess, we would check by multiplying, and we kept going back and forth until we finally found ones that multiplied correctly. That's one method to factor any quadratic equation, even when they start to get more difficult with numbers. Now it can be a long time, especially if you have a lot of factors to check, but sometimes it's a quick method to kind of get through and just break it up. But There's also another method. We can use guess and check, or if you're a step-by-step person that likes it really laid out, you can also do this process. You can look for, you can look for two numbers that add up to b and multiply to AC. I'm going to go over an example of this really quickly here. And then you can use those two numbers to rewrite the quadratic as four terms, and then use factoring by grouping to then factor the polynomial as well. So let's do that. With this example here, factor the following quadratic equation. Okay, so first we need to identify what's a, b, and c. Well, a is 12, it's my leading coefficient. B is 7, it's the one in front of the x term. And my constant c is negative 10. Don't forget the negative sign in front. And if I'm going step by step, I need to find two numbers that add up to b. So b is 7. So I'm looking for two numbers that add up to 7, but multiplied to equal AC. So a times c is 12 times negative 10 is negative 120. So I need two numbers that multiply to make negative 120. But the same two numbers also have to add up to 7. So this is the hardest part. This is where I have to play around with some numbers a little bit. I do know one's positive and one's negative. So let's try, again, I pull up my calculator and I'm just going to look for factors of 120. So let's do 120 divided by 5. So 5 times 24 is a factor of 120. But 5 times 24, the difference is not 7. So I'm not liking that one. So let's do 120 divided by 8. And 120 divided by 8 means that 8 times 15 is 120. And I like that because I can get 15 minus 8 to give me 7. So my two numbers then are 15 and negative 8 and 15 times negative 8. There's my two numbers that multiply to negative 120, but that they add up to 7. Now, how does that help me out? What that lets me do now is take my trinomial with 3 terms and then rewrite it as a polynomial with 4 terms. I still have 12x squared at the beginning. I still have negative 10 at the end. But what's different is that I split this 7x into the two numbers that add up to 7. So we've got plus 15x minus 8x. There we go. 4 terms. 1, 2, 3, 4. Now we get to use factoring by grouping. I love factoring by grouping. First, change everything to plus and negative. So plus negative 10. And then you split it into 2 groups. And you look to factor what is in common with each group. So in this first group, 12x squared and 15x, I'm going to factor out a 3. That's in common with 12 and 15. And there's an x in common. So I'm going to factor the 3x, and it leaves 4x plus 5. Now I'm going to do that with the other one. Let's pull out some red. And I'm going to look at what's in common between negative 8x and negative 10. I can factor out a negative 2. And what do I have left? 8 divided by 2 gives me 4. Negative 10 divided by negative 2 is 5. I still have the x, 4x plus 5. Now here's where I've struck gold, right? I have the common binomials, 4x plus 5. So I can put that in common. And I have left a 3x plus negative 2. Or 3x minus 2. And there is my factored form. This factored form, these two binomials are the same thing as this trinomial right here. So that's a step-by-step approach to factoring quadratics. It might feel a little bit longer, but if you do it enough times, you start to get really quick at it, and it sort of prevents you from having to guess and check and guess and check and spin your wheels. You can just go through the system and crank it out and get your solution. All right, we're doing some good examples of factoring, right? Let's look at some special cases. We have special trinomials or special cases of factoring to keep our eye out for. Those are the difference of two squares. So sometimes you might see two things being subtracted and they're both squares of something. They'll factor out into this form, a minus b and a plus b. We'll do an example of that. And then you also have perfect square trinomials. If you can recognize a certain pattern or go to your factoring technique, sometimes they factor into the same binomial. So let's run through each one of those as well too. Factor the following quadratic equation. What do we got going on here? Well, one thing that we didn't do in the previous examples is you always want to look for any common factors right off the bat. When I look at 27 and 12, they both have a factor of 3, right? Well, let's make life easier and factor that 3 out. And we've got what's left inside. 27 divided by 3 is 9x squared. And 12 divided by 3 is 4. And now we've got something squared, because 9 is 3 squared. And we have 4, that's 2 squared. I've got a difference of 2 squares. Well, the difference of 2 squares, again, the formula is, if you recognize that pattern, it factors into a minus b, or a plus b times a minus b. And in this case, that would be 3x minus 2 times 3x plus 2. I still have the 3 in the beginning that I factored out, but this is the same thing as that in factored form. And you can multiply and check this out. I definitely encourage you to do that, but I think you'll see 3x times 3x gives you the 9x squared. Negative 2 times positive 2 gives you the negative 4. What makes this a special case is when you do the outer and the inner terms, 3x times 2 gives you 6x, but then negative 2 times 3x gives you minus 6x. They both cancel each out and turn to 0 when you multiply them out. That's why there's no middle x term in the polynomial. So there you go. That's a difference of 2 squares. Keep your eye out for practicing some of those this week. Next, look at a perfect square trinomial. So here we've got a trinomial. I've got some big stuff here. Let's go ahead and factor out anything common here. So if I look at 36, 48, and 16, they all have a 4 in common, right? So let's factor out a 4. Move that in the front. And what do we have left after we factor that out? 36 divided by 4 is 9a squared. Ooh, 9 is something squared, I like that. 48 divided by 4 is 12. So minus 12a. 16 divided by 4 is 4. And here I've got something squared. 9 is 3 squared. 4 is 2 squared again. And I've got a middle term of negative 12. I'm thinking this might be a special case where it is 3a minus 2 times 3a minus 2. Let's just double check though by multiplying it back out. 3a times 3a is 9a squared. 3a times negative 2 is minus 6a. Negative 2 times 3a is minus another 6a. And negative 2 times negative 2 gives me the plus 4. And my middle two terms combine to make negative 12a. So I've got everything that I want, but I can go one more step and say, all right, well then this factors into 4. I had the 4 in the beginning, times 3a minus 2. But since I have 2 of them, let's do 3a minus 2 squared. And there is factored form of that trinomial. All right, we're cruising along, right? I wanted to go over an example of solving a problem by factoring. We've done a lot of examples, done a lot of factoring methods. You can actually solve equations and do some problem solving with factoring as well too. So let's take a look at this problem. The length of a regulation football field is 14 more than twice the width. If the area of the football field is 6,360 square yards, what are the dimensions? Let's draw a picture and try and make sense of what's going on. So we've got a football field. I'm going to draw a rectangle over here. And I'm told some stuff about this rectangle, right? The length of the football field is 14 more than twice the width. So twice the width, 2 times w, and 14 more is plus 14. So there's the length, and there's the width. 2w plus 14 and w. Okay, I've got my dimensions. I'm starting to translate the problem into the right picture, understanding it. I'm told some information about the area. The area is 6,360 square yards. And I want to find the dimensions. I want to know what the length and the width are. If you remember, the area is equal to length times width on every rectangle. But we know some things. We can substitute some things into using our algebra. Let's put 6,360 in for the area equals my length. Let's put this expression in for the length, 2 times w plus 14. And my width is just width. Now the reason I substituted this expression in for length is now I have an equation with just one variable. The only variable in here is w. And we can start to solve it out. I can take one equation with one variable and solve it. And we're going to use factoring to solve out this quadratic equation. To do that, I need to get ax squared plus bx plus c. And I need to get 0 on the other side. So we got some work to do. Let's distribute this w. And we get 2 times w squared plus 14w. And I'm also going to subtract this 6,360 from both sides to get 0 on the left side. So there, I've just rearranged it all. I've got a is 2, b is 14, c is 6,360. And just because I can do it, let's go ahead and do some algebra. We'll divide everything on both sides by 2 to simplify it out even further to help us out. So we've got 0 equals w squared. I got a leading coefficient of 1. I like that. Plus 7w minus 3,180. To make it a little bit easier to work with. I've got a leading coefficient of 1, so now I just need two numbers that multiply to c, so negative 3,180, but add up to 7. And if you play around with that, let's see here. I'm going to pull up my calculator. I'm going to do 3,180. I'm just going to look for factors that divide it evenly. So 3,180 divided by 60. And the numbers I'm looking for are plus 60 and minus 53. Those add up to 7, but they multiply to negative 3,180. Now here's why it's nice getting it to equal 0. Is because when you have it 0, these two things are multiplied. The only way you can multiply two numbers to get 0 is if they equal 0. One of those numbers has to be 0. So I'm looking for numbers I can put in for w to make either of these binomials turn into 0. One of those is negative 60. If I put that in for w, I get negative 60 plus 60. And that turns into 0 times all of this. So that's one solution. The other solution is positive 53. 53 minus 53 is 0. And that 0 times all of that turns into 0. So I've got two solutions to this quadratic equation. And I've done all my algebra. Now let's go back and revisit this problem. I'm asked to find what are the dimensions. So I'm trying to find the length and width of this football field, right? Negative 60 doesn't make any sense because I can't have a negative feet wide football field. So I'm going to ignore that one and just use the 53. And what do we got now? The width, we just solved for w. The width is 53 yards. And the length is equal to 2 times the width. So 2 times 53 is 106. 106 plus 14 is going to be 120 yards. So now we've answered the question, and we used factoring. Well, we used a quadratic equation to model this problem. You'll see a lot of area and length and width problems as you do quadratic equations. And then we used factoring to actually solve out the equation. But there is my dimensions. So to solve a quadratic equation by factoring, let's sum up what we just did. First, you get your equation and you get it into standard form. We have to have it equal to 0 to be able to use factoring. So ax squared plus bx plus c, all that kind of stuff. Then we factor on the left side. So we factor it out how we can, get our two numbers, do whatever we can. And once we've factored it out, then we look at each binomial separately and say what value of x makes it go to 0. And those are our two solutions. Oftentimes we have two solutions as we deal with quadratic equations. Lastly, I just want to touch a little tiny bit on simplifying square roots because we're going to use square roots a lot next week because square roots are the opposite of squaring. If we're dealing with quadratic equations and x squareds, then we're going to need to be comfortable with square rooting. So first of all, let's talk about simplifying square roots. To simplify a square root means we're trying to square root factors that we can and leave inside the square root factors that we can't deal with. So here I've got the square root of 120, but let's think. I may not be able to take square root of 120, that's an irrational number, but maybe there's parts of 120 that I can't. So let's list out our perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, and 64. We can keep going and going and going, right? But you want to be really familiar with these as we're working with square roots because I can square root any of these and they turn into a perfect number. Now what I'm looking are any of these factors of 120? In other words, can 120 be divided by any of these numbers? It can, and the only one is it can be divided by 4. So we want to look for the largest one that is a factor, and what that means is I can split 120 into the square root of 4 times 30. Now the way square roots work is then you can rewrite it as two separate square roots. That's the same as the square root of 4 times the square root of 30. Now the square root of 30 I can't deal with anything. There are no factors of perfect square factors in 30, but the square root of 4 is nice because I can factor that, or I can square root that. Square root of 4 just becomes 2 because 2 squared is 4. I'm still multiplying by the square root of 30, but there we go. That's rewriting our radical expression in simplified terms, and that's a helpful skill to be able to know when you're dealing with quadratics. So this is the same. Square root of 120 is the same as 2 times the square root of 30. You can also go in reverse. What if you're multiplying two things together? So we have the square root of 3 times the square root of 12. Well, when you're multiplying, you can combine them. That's the same as the square root of 3 times 12. Well, let's simplify that now. The square root of 3 times 12 is the same as the square root of 36, and that's one of our perfect square factors. The square root of 36 is just the same as 6, because 6 squared is 36. So this, if I try and do them separately, the square root of 3 is an irrational number, the square root of 12 is an irrational number, but if I multiply them together, I end up with a perfect number. They equal 6. So you can multiply together square roots, and you can also factor apart to help simplify square roots. Okay, there's a lot today, right? A lot about factoring, a little bit about square roots. We went through all of these things. Make sure you're practicing factoring all sorts of different problems. I want to be able to give you any sort of quadratic equation. I want you to run through the steps to see if you can factor it out and rewrite it in a different form. And then start messing around with radicals a little bit. Make sure you're reading the textbook for more examples on all of this. And I'll be giving you feedback throughout the week. Hope you have a good week 5 as you're getting into the problems. Let me know if you have any questions.